I'm Mike with Electric Lab. Today, the subject matter is motor overload protection, but perhaps not what you think. Typically, when we're talking about motor overloads, we're talking about the sizing and some of the percentages in the NEC that we need to do, calculations and things like that. What we're going to be talking about is very specifically connection points and how to actually wire the overloads on a motor starter. The components we'll be using in this will be the ones that are on our EL430 control trainers. And so we're going to be referencing those a lot, and we're also going to be showing you the direct connection point so you have an idea of how that works. So let's get started. Okay, so before we begin, you'll notice this is a new portion of the cover of our new 4th edition, and I revised the title. Formerly, the title was Industrial Electrical Control Systems. I decided to shorten it because that was really too long. And I shortened it to Electrical Control Systems because what our training equipment does and what this curriculum does is really pinpoints it much better. That being said, previously we didn't really cover overloads, and we have added that into it, but we keep it at the aspect of the wiring portion of it for learning the sizing. And as I mentioned earlier, the code-related issues regarding this, you're going to want to refer to the curriculum you're using as the base with your program. Typically, when folks are using our training equipment, they also are using other products that go along with the classroom training, and this training is more for the lab. So here we go. So overloads are defined in the NEC as operation of equipment more than its normal full load rating, or more than a conductor's ampacity, which, if it is allowed to persist for a long enough period, can cause damage and overheating. Short circuits or ground faults are not overloads. So, overload control contacts. In this photo, notice the contacts numbered 95, 96, and 97 and 98. The 95, 96 contacts are normally closed contacts. The 97, 98 contacts are normally open contacts. You can see where they are marked right here in the circle. NC 95, 96, normally open, 98, 97. The typical use for these contacts is as follows. The 95, 96 contacts are connected as part of the control circuit, and when an overload occurs, these contacts open to de-energize the control circuit and the motor to avoid damage. So that should tell you the power supply for these has to come really kind of before the control wiring, right? The 97, 98 contacts are connected as part of a circuit that powers, let's say, an indicator light, so that when the overload occurs, these contacts close and the indicator light is energized, providing a visible indicator that the overload has occurred. Now, here's an excerpt from our book, The Wiring of Overload Control Contacts. There are many variables to ladder logic depictions for overload control wiring. A typical example is below here. So you can see in the circle at the top, that's your overloads. That's our symbol for overloads that we use in our Electric Lab book. And then, of course, there's the 3-phase motor. Also in the logic below, it's showing the overloads as a normally closed contact. So that would be the typical style, if you will, that you would see in a diagram. Now, here's the physical contact part of it. And this is showing you, first of all, to the left there, that's your contactor, machine control relay. And then to the right, there's your set of overloads. Now notice we have, first of all, we'll deal with the red wire here. That's tapped into what we'll call C phase on the contactor, bringing power before going through the contactor to the 95 and 96 sets of contacts. So those are normally closed, and then goes to the control circuitry. And then the 97 and 98 contacts, you can see, are opposite of that, and that would be the contacts used to control an indicator light to indicate power's been pulled out by the overloads because of an overload, and then that would turn on that indicator light, indicating, visibly that, hey, there's a problem. Overload operation. The operation of a set of overloads and the calculations required to determine appropriate settings is not covered in this material. Refer to your classroom textbook for this learning. So just really kind of verifying that. But while we have this up here in a great close-up shot of this, this is the TK26E made by Fuji, purchased from Automation Direct. Of course, that's where all our components, or predominantly our components, come from. And you have the big yellow dial there. That is where you can actually set what your, we'll call it your trip setting would be at. And to determine that, that is all something you're going to get out of the NEC and a different teaching outside of this. And then you have the blue, I'll call it the blue knob. That is your reset. Talk a little bit about that when we get to the end of this, but you can actually push and test it and reset it. I'm going to use the example just like a GFCI. However described below, you will find the basic operation features, so kind of explaining some things that happen with it. Adjustable current setting. This dial is used to set the specific amount of current draw required to be considered in overload. The reset button. This is used to reset the overload after it has been tested or an overload has occurred, of course. And then the test button. This is used to initiate a test mode of the overload function. And here is the instructions for the Fuji Brand TK26E set of overloads. And of course, all of this is shown in our new 4th edition of the book. But you have here to the left, it's showing the trip indicator is white, indicating here in black just for explanation purposes, but it's showing in the tripped state what it looks like, and then in the reset state. So, and then you can adjust, they're showing the automatic reset, and then of course you can do a manual reset using a screwdriver. The operating indicator, where the thermal overload relay operates, the white trip indicator in the operating indicator window will be hidden, and the white trip indicator will not be hidden when tripped in the automatic reset state. In the sequence checking, press the white trip indicator in the direction shown by an arrow to perform sequence checking. In resetting method, when the thermal overload relay operates, first remove the cause of an error such as an overload, figure out why that happened, and then press the reset bar. Press the reset bar until it comes to a stop, and the resetting will not be possible unless the thermal overload relay is sufficiently cooled down. Keep that in mind. Changing from manual reset to automatic reset. Change from the manual reset to the automatic reset according to the following procedure. Or change from the automatic reset to the manual reset according to the reverse procedure. Open the front cover using a screwdriver or a similar tool. Press the reset bar and turn it clockwise by 90 degrees. And confirm that the reset bar is held pushed in. And of course, close the cover back. And a last note here. Attention must be paid to the fact that in case of a 2-wire control circuit, the motor is automatically started when the thermal overload relay is automatically reset. Sizing of motor and branch circuit overload protection can be found in Article 430.31 and 32 and other sections in that article. There are several factors that contribute to proper sizing of overload protection, and this must be understood to protect from equipment damage or fire. Okay, so let's take a look at this motor starter. As you can see, I have the power supply coming out of what I'm calling the third pole or C phase, coming down to our set of contacts, 95 and 96, going into 95, coming out of 96, and this would goes to power your control logic. That way, if this kicks out, this normally closed set of contacts kicks out, it's going to shut down everything before it's allowed to damage equipment or a motor or anything like that. Very simple, but I wanted to kind of bring that to the screen here to kind of show you exactly what that looks like. There was mention of a little door on the front here that opens up and gives you the access to the components to adjust and set your ampere setting on it, how to test your reset. You can hit that and then reset it. Basically, you got to take a screwdriver and go in there and reset it, just like a GFI, as I'd said. So, just want to kind of show the simplicity of that, how that works. We could also have another set of wires coming off of here, going off of the 97 and 98, which would be a power supply going to it, coming out of it and going to, as we'd said, an indicator light, which could indicate if this is tripped out, then it's going to give you a light to say, hey, you've got a problem. So, okay. Well, I think that's everything that we wanted to cover as far as this little segment is concerned, and hope that is very helpful. Be sure and check us out at electriclab.org. And my name is Mike Barley. Thanks for watching.